Hello and welcome to the next video in our web application testing series. In this video, we'll be focusing on file upload vulnerability, a fundamental feature in web and mobile applications that is especially attractive to attackers due to the level of access it potentially provides. Improper handling of file uploads can allow attackers to upload malicious files, which may lead to severe consequences. And that includes remote code execution or even gaining remote shell on your server. So stay tuned to learn more about this critical vulnerability and how to defend against it. Before we dive in, if you haven't already, please subscribe to the channel for more security content and don't forget to like this video if you like the content and the way that we present and teach security concepts here. Let's begin with the basics. What is file upload? File upload is a critical functionality found in most modern applications. Technically, it allows the client, which is typically the user, to send various types of files to the server. This could include uploading a driver's license, a completed form, important documents, or a photo taken directly from a phone's camera. From a business perspective, file upload is essential for a variety of use cases, such as customer onboarding, example, submitting identity documents, collaboration, for example, sharing media files or documents, data collection, submitting forms with attachments, and service delivery, for example, designers receiving creative briefs, lawyers receiving signed contracts. While this functionality is crucial for business operations, it also introduces significant security risks if not properly implemented. But where exactly does the security risk lie in file upload functionality? The danger comes from the fact that file upload allows users to store arbitrary files on the server. Depending on how the application is designed, an attacker might even be able to access or execute those uploaded files. And that's essentially the worst case scenario. Some of the key risks introduced by the insecure file upload include remote code execution or RCE, which is if an attacker is able to upload a script file such as PHP, ASP, or JSP, and the server stores it in a publicly accessible directory. The file could then be executed by the server. This could allow the attacker to run arbitrary commands and gain full control over the system. For example, an attacker uploads a shell.php file in a server, then accesses through a particular URL, which we have in here, HTTPS, your domain, and then uploads, and that is the name of the file that the attacker can access it. Malware or virus uploads. In an application where uploaded files are shared with other users, such as resumes, invoices, or attachments, malicious actors may upload infected files, for example, PDF documents, Office files with macros or executable programs. If another user downloads and opens the file, it could compromise their machine. This is particularly dangerous in platforms like job portals, CRM systems, or file sharing services, where users trust the content being shared and are more likely to open it without suspicion. Cross-site scripting via file upload. Attackers can upload specially crafted files such as SVG images or HTML documents that contain embedded JavaScript code. If these files are rendered in the browser without proper sanitization or content validation, they can trigger persistent cross-site scripting attack when viewed by the other user. For example, an attacker might upload a malicious SVG containing JavaScript, and then the victim later views the file in the browser. The script gets executed in the victim session and potentially leading to cookie theft, account hijacking, or privilege escalation, or even denial of service. The script executes in the victim session, potentially leading to cookie theft, account hijacking, or privilege escalation. If you want to learn more, I have another video on cross-site scripting. Check the channel and learn more about cross-site scripting and how it technically works. Denial of service is a type of attack where the attacker can exploit the file upload feature to launch denial of service by uploading very large files or flooding the server with numerous upload requests. This can exhaust system resources such as disk space, memory, or CPU, potentially causing crashes, slowdowns, or even making the application unavailable to legitimate users. In some cases, repeated large uploads may also trigger unintended side effects such as log file bloat or backend server failure. Content spoofing and MIME type bypasses. Attackers can disguise malicious files by spoofing the file extension or MIME type. For example, a file named resume.jpg might actually be a PHP script or exe file or another dangerous type. If the application relies solely on the file name or the MIME type reported by the browser or the forum, it can be easily fooled. This can lead to situations where a server stores and potentially executes malicious files, believing they are harmless images or documents, especially dangerous if these files are accessible or processed in any way by the application. Especially dangerous if these files are accessible or processed in any way by the application. Path traversal and file overwriting. Improper handling of the file names and paths can allow attackers to perform path traversal attacks, leading to serious consequences. By manipulating the file name during upload, an attacker may be able to do multiple things which we discussed on. They can upload files outside of the intended directory. They can overwrite sensitive files such as configuration files, scripts, or logs. And they can also navigate the file system using sequences. As an example, they can have multiple of these and say and then it is etc.passwd. If not properly sanitized, these techniques can lead to loss of data integrity, application malfunction, or even complete system compromise. In September 2020, a critical vulnerability was discovered in a popular file manager plugin for WordPress with over 700,000 active installations at the time. The vulnerability allowed unauthenticated attackers to upload arbitrary files, including PHP web shells, directly to the server. The impact? Widespread exploitation in the wild. Thousands of WordPress sites were compromised in a short span, and the issue was assigned a CVE. When it comes to file upload functionality, there are multiple layers involved, and the first is the front end. The front end is the user interface through which a file is sent to the backend server. This is typically implemented using an HTML form or JavaScript-based logic. During security testing, it's important to examine the front-end controls to understand what kinds of client-side restrictions are being applied, such as allowed file types, size limits, or validation logic. These restrictions are often enforced using JavaScript or HTML attributes like accept in file input fields. However, keep in mind, client-side controls can always be bypassed. They are useful for user experience but not a reliable security measure. In some cases, vulnerabilities in the front-end file handling logic can even lead to attacks such as cross-site scripting via improperly handled preview responses or cross-site content hijacking, where attackers trick the application into rendering malicious content. Next comes the backend, the layer where critical security controls must be implemented. This is where most of the actual risk mitigation should happen and where things can go seriously wrong if not properly handled. Backend controls are enforced by the server and are responsible for validating and handling the file after it is received, but before it is stored or made accessible. These controls must not rely on anything the client says, such as the file extension, MIME type, or size, as all these can be manipulated by the attacker. If these validations are missing or poorly implemented, the server may accept and store malicious files, allow unauthorized file types, save the file in unsafe location, fail to detect past traversal or file overwriting attempts, and proper backend validation is essential for preventing exploitation of the file upload features. Another critical consideration when it comes to file upload is proper file validation. When a file is uploaded, several attributes can help identifying the file type and determine how it can be handled, including the file extension, content type header, and the MIME type. However, these values are easily spoofed. A user can rename a file and change its extension, even if the frontend tries to enforce restrictions like by blocking certain extensions or things like that. These controls can be bypassed using proxy tools like Websuit or by directly crafting the request. We'll be practicing this in our labs. Understanding the content type header. The content type header in an HTTP request indicates the media type, MIME type, of the file being uploaded, for example, image or PNG or application PDF. But here's the issue. The value of the content type header can be manually altered and may not reflect the actual content of the file. So how does the server know what kind of file it is really? Magic bytes, the real identity of a file. One reliable method is by inspecting the file's magic bytes, the unique sequence of bytes at the beginning of a file that identifies its true format. For example, JPEG files typically start with what you can see here. PNG files start with 894E and PDF files are shown here. By comparing the magic bytes with the declared MIME type and file extension, the server can more accurately verify true nature of the file and defend against spoofing attacks. A robust file upload implementation should always validate file extension, MIME type, and magic bytes. Limitations and vulnerabilities in the application leading to file upload vulnerabilities. So here we're going to discuss what makes your application basically vulnerable. So the first thing that we want to cover is unrestricted file upload. This occurs when users are allowed to upload files without restrictions on file size, type, quantity, and without proper validation on either the backend server or frontend. Without such restrictions, attackers can upload malicious files leading to potential exploitation. Next, content type manipulation. The content type header identifies the MIME type of the file being transmitted. Since this value is provided by the client, attackers can modify it before sending the request to the server. If the server side relies solely on the content type for validation, it can be tricked into accepting harmful files. Extension filtering bypass. Some applications check the file extension to allow only specific file types. Attackers can bypass these by using double extensions. For instance, they can use file.jpeg.php, renaming the file extension before uploading, leveraging other bypass techniques depending on how the server handles extension checks. This is particularly dangerous if the server executes files based on their actual content or allows certain file types in executable directly. MIME sniffing. MIME sniffing occurs when a browser tries to guess the file type based on its content instead of trusting the server declared content type. This can cause security issues if the server serves an untrusted file with a safe content type, such as text or plain. The browser ignores this and interprets the file as something dangerous. And then a text HTML renders as an HTML, application JavaScript executes as JavaScript, and text plain misinterpreted as HTML.js and executed. This can lead to cross-site scripting or unintended script execution even when the server attempts to be safe. File traversal via file upload. This vulnerability combines file upload with directory traversal attack. An attacker manipulates the file upload path to store the file and outside the intended directory, potentially overwriting critical files. Client-side validation only. Relying solely on client-side validation is insecure because the client-side control can be bypassed. Even with perfect front-end validation, it can be bypassed by intercepting and modifying the request before it reaches the server. Okay, now it's time to put our learning into practice with some hands-on lab. We'll start with remote code execution via web shell upload.
Okay, first lab we're going to look into remote code execution via web shell. We are going to upload a shell to read the content of the file that is here, and we just access the lab to see how we can do it. So if you can see, it's just a usual website with the content. We have a my account that we basically need to log in with the credential that has been provided, and there we need a PHP file. So this is the avatar that we can upload. This is where we can upload the file, and we need a PHP file to read the content of this file. So what I'm gonna do is that, yeah, but of course we can go through the process of writing the code and learning how to write or that's simple PHP code. But what I'm gonna do is just to simply say read PHP shell to read the file, so and then see what the AI will come back, right? So we just want to learn and use the new technology that we have to better do our job and save out a bit of a time, right? So of course the file get content is the function that we basically use to read the content of a file, and then the file that we want to read the content is this file. So we just replace that in here and then save. So what we're gonna do is that we have to upload that file. Okay, so we have the file. Now we hit the upload and then go back to our account. So you can see that of course the avatar is not loaded, but if I go to the HTTP proxy, then you see we have a lot. We've also posted that exploit that PHP in here, and then we got a 200, and now you can see that we fetched the my account and then the avatar that was in question, and then you can see that we got the flag here as well. So if I send this to repeater and send it again, so you see that we're basically reading the contents of the exploit.php. This in a usual scenario, instead of exploit.php, there should be an avatar which will be loaded as your image in here. Well, we have uploaded a PHP and then we give it a code to read the content of a file, and it's returning that file for us, which if we go here and then submit that solution, it should work, right? So now let's move to the next.
Up next, we cover web shell upload via content type restriction bypass.
This lab contains a vulnerable image upload function. It attempts to prevent users from uploading unexpected file types, but relies on checking user controllable inputs to verify this. So technically what it means here is that we are trying to upload an image file. The server checks that what we are uploading is only image, but the checking is not reliable because we can control what the server checks and how the server checks it. Similar to the previous lab, it says we need to upload a basic PHP shell to extract the content, and we have a username and password. Okay, so with proxying the traffic, we are going to head to our account and the credentials that we had there. So here we have a file upload functionality. It's like basically an avatar upload. While we're proxying the communication, we can go and say let's look into that. So we bring our exploit file, we upload it, hit upload. Okay, so it's been up. It says the file hasn't been allowed to be uploaded, right? So what we do, we go back to our main page, and what we can do is that if we go to the proxy tab, HTTP history, and then find that post request where we basically posted the file. So here we just send this to our repeater, and then you can see that it says it's not possible to accept. It's basically checking, says file type application PHP is not allowed, right? Only image JPEG and image PNG are allowed. So we're saying that the file type is the question here. So what we can do is that we can look into see if we can change that file type, right? So what we will do is that we go here, we modify this with what the request has asked, and then we hit send, and then we get the 200, meaning that our request has been accepted, right? So we just need to get the avatar. So if I just go and reload this page, right? So I can see that there would be a request for my avatar, and then that basically requests the exploit.php that we have just uploaded, and then you would see the answer to the lab, which is here, and you can submit it to the lab. So basically what happens here is that the application relies on the user to define what is the content type, and solely relies on this aspect to define what type of file is being uploaded, right? So what type of file we are sending to the server. And because it's something that is controlled by the user, we can just simply change and modify this to any value that we want, and thus bypass restrictions.
Up next, we cover web shell upload via path traversal.
Okay, the next lab we are going to combine a file upload vulnerability with a path traversal. Within a path traversal vulnerability, the goal of the attacker is to move from the directory that they are, and then either upload a file to a different location or read file contents from a different location, and that's called, in a nutshell, path traversal. So we're going to combine that with a file upload vulnerability to read the secrets, as in the previous lab that we've discussed. So similar to the previous ones, we're gonna follow the same path. We're gonna just log in and then upload this exploit file that we have created in the previous videos, and we're gonna upload it, and it says the file avatars exploit.php has been uploaded, right? So when we go back, if I go to my proxy, so then I would say, I would see that we basically are looking into posting the file. That's the exploit.php, and then we are reading the file. But the problem that is happening here is that we are reading, the server is sending back the content of that file, right? Instead of executing that. This can be because of multiple reasons, but because we are in a lab that is also saying that we have path traversal here, so probably we need to upload it to a different directory where we will be able to execute this instead of just reading it when we are getting and where we are requesting that. So we go to our post request where we uploaded this request to the server, and then we attempt to do a bit of a path traversal, right? Okay, so instead of uploading this to my account avatar, we are gonna change the directory that we are uploading this, and the way we're gonna do it is that here we're gonna add // where that means go one folder back. Technically we are uploading it to my account. Let's see what will be the outcome. And it says the file avatars exploit.php has been uploaded. So technically it's not basically looking into, or it's not accepting what we've done, right? So there probably is some sort of validations in place that it's blocking us. Let's see if we URL encode this one. So to URL encode it, so we just put the URL encode version of that, and then send. Okay, so it says the file avatars then exploit has been uploaded. So that means potentially now the server is accepting what we sent. So if we go back, and then because we've technically bypassed this avatar, I can just remove it because we want one folder above and then send it. Yep, you can see that we've got the content. The reason why I removed the avatar is because we actually moved, we did a path reversal. We moved one folder above avatar. We technically stored this file into my account, and if you read this one, it's basically saying avatars going one folder back, which would be again in my accounts, and then it's exploit.php, and that's where we have uploaded our file, and that's how we got the response from what we wanted. So that's gonna be this lab.
Okay, now it's time to discuss about how you can protect your application. So we have discussed this in other aspects and in other sections of the video. So I'm gonna walk you through how you can protect your application. So first thing first, limit file extensions and mimic types. So define a whitelisting only allows what you need in your application and what is required in your application, and only allow users to upload those type of files. Always do the validations in the server side and do not rely on client side validation. They are good for user experience, but they're not enough, and they are not enough for ensuring the security of your application. Always validate the file type and randomize the file name. When you're receiving the file, before storing it in your storage, make sure that you randomize the file name. You change the file name. So even if something happens and somehow the attacker get access to where you upload your files, they wouldn't know what's the name of the file that they have uploaded. So that technically reduces the impact and is sort of a layer of protection. Change the file location. Do not store the file in the same place that the application is sitting and in the application root directory. Isolate uploaded files. So make sure that you apply sandboxing and sort of isolation for the file that you uploaded, so that they can't access, and even if the attacker accesses that directory and get a remote code execution from there, they can't move to other aspects of your application. Scan uploaded content. Use content scanning tools and antivirus software to detect and block malicious files before processing them. Limit file name length. Restrict the maximum allowed length of uploaded files to prevent buffer overflows or path manipulation attacks. Enforce file size limitations. Set a maximum allowable file size to prevent denial of service attacks through oversized file upload. Restrict file upload permissions. Allow only authenticated and authorized users to upload a file. And that wraps up our deep dive into file upload vulnerability. From how they work to exploiting them in labs, and finally how to secure your application against them. If you found this video helpful, make sure to give it a like. It really helps support the channel. Don't forget to subscribe and turn on the notification bell so you wouldn't miss our next security walkthroughs and hands-on labs. And I'd love to hear from you. Drop a comment below and let me know your thoughts, questions, or even your own experience dealing with the file upload vulnerabilities. Thanks for watching and stay safe out there.